If you've ever stared at a physics problem and felt like it was written in a different language, even though you do well in math, chemistry, or biology, you're not alone. This happens to a lot of smart, hardworking students. And it's not because physics is too advanced, or because you're not a physics person. Physics feels hard for specific structural reasons. And once you understand those reasons, the subject becomes much more manageable. One reason physics feels difficult is that it rarely tests just one skill. In a single problem, you're expected to understand a physical situation, represent it with diagrams or symbols, apply mathematics correctly, and interpret what the results actually mean. Most subjects let you practice those skills separately. Physics asks you to integrate them all at once. That difficulty isn't accidental. It's built into the subject. Learning physics means learning how these skills work together, not in isolation. Another major challenge is that physics is highly cumulative. Ideas stack on top of each other. In the beginning, you learn motion, and then forces explain those changes in motion. And then you build energy momentum on top of those ideas. And then the future topics after that depend on almost all of them. So if one layer is weak, everything above it can feel unstable. This is why students often feel lost even when they're putting in real effort. The problem usually isn't motivation. It's a missing or fragile foundation. And the solution isn't rushing ahead. It's actually going back to rebuild that foundation. In everyday life, you rely on your intuition, but physics often asks us to think in idealized situations. In this problem, there's no air resistance, the surface is frictionless, and the system is perfectly isolated. At first, this can feel unrealistic or even wrong, but these simplifications exist for a reason. They help isolate cause and effect. Physics doesn't throw intuition away, it actually refines the intuition you already have. Over time, your intuition becomes sharper, more precise, and more reliable. One of the biggest reasons why physics feels overwhelming is because of how it's commonly taught. Many students first see equations before they even understand what these equations mean. This can lead to memorization without understanding, anxiety about choosing the right formula, and frustration when problems don't look familiar. Physics is not about hunting for equations. It's about recognizing patterns in behavior, how objects move, how systems change, and what stays constant, and then using math to describe those patterns. None of these challenges mean physics is not for you. They mean that the subject is demanding in a very specific way, and that demand can be met. Physics becomes clearer when you focus on what is changing, what is staying the same, why the system behaves the way it does, and what assumptions are we making. When you slow down and build understanding first, the math becomes supportive instead of intimidating. This is the approach I take when it comes to teaching physics. I love to focus on understanding ideas before equations, building the intuition alongside the math, and developing tools and strategies that transfer from one problem to the next. I will be the first to say that physics is challenging, but it is learnable. When you approach physics as a mindset of thinking about the world and not just a collection of rules, it starts to click. One of the best places to begin reinforcing the basics is with motion, because it's where many physics students first begin their study of physics. And over the next few videos, I'm going to be emphasizing key ideas related to motion. If you don't want to miss out on those videos, please consider subscribing to the channel. It would mean a lot to me. And while you wait for those videos, consider watching one of my previous ones in this corner or in that corner. Thank you for watching, and I will see you in the next video.